At this point in our analysis, we've completed the first 3 steps. We've created our geometry, assigned material properties, and created a study. Now it's time to go on to the next step, defining the operating environment for this part. When I introduced this exercise, I mentioned this plate was going to be held on one end and pulled on the opposite end. That's a good description of the plate's operating environment, but we have to be able to communicate this to simulation. The way we do that is by using external loads and fixtures. Let's begin with fixtures. As the name indicates, fixtures are used to prevent motion in our part. When it comes to linear static analysis, like we're performing here, it's important that our part not move. It has to be restrained so that as we add a load, the part doesn't simply slide away. If the part had the ability to move, we would not be talking about static analysis. We would instead be dealing with dynamic analysis. In real life, you restrain a part by using a variety of methods. You can use fasteners like screws and bolts. You can also use glue or welds. There are many possibilities. In simulation, we represent these real-life methods using a collection of restraints. Using these fixtures, or a combination of them, we can simulate just about any type of real-life restraints. Because there are so many types of fixtures, we'll only focus on the fixed geometry fixture in this example. In later examples, we'll examine several other types, and toward the end of the course, we'll have a section devoted exclusively to fixtures that you can use as a reference. Again, in this example, we'll be using a fixed geometry fixture to keep the part from moving. Now, applying fixtures is simple. If you look at the simulation study tree, notice the listing labeled Fixtures. If I right-click on this item, a pop-up menu will allow me to select a type of fixture. I can also use the simulation drop-down menu, Loads Fixture, Fixtures. In this case, I'll simply use the drop-down of the Fixtures icon from the simulation toolbar. Here, I can select the type of fixture I want to add. For this example, I'll select Fixed Geometry. The Fixture Property Manager appears. You can see the Fixed Geometry icon is selected, and an example of the fixture is shown at the top. Below this are the various types of fixtures organized into standard and advanced fixture types. An example is shown for each type as I click through them. Fixed, roller or slider, hinge, symmetry, circular symmetry, use reference geometry, on flat, cylindrical, or spherical face. I'll be using fixed geometry in this case. The fixed geometry fixture is a rigid support. It prevents all translation, that is, all sliding motion in the X, Y, or Z direction, as well as all rotation. If I hover the pointer above the highlighted selection window, you'll see a tooltip indicating you must select faces, edges, or vertices to apply the fixture. I'll rotate the part so I can see the back end of the plate. As I hover over the part, you can see symbols appear indicating where the fixture will be added. I'll select the back face, and the fixture is added. The appearance of the symbols can be controlled using the box at the bottom of the Property Manager. If you wish to hide them completely, simply uncheck the Show Preview option. If you wish to change the scale or color of the symbols, you can do so using these settings. For now, I've selected the only face I wish to apply the fixture to, so I'll click OK. The simulation study tree now shows Fixture 1, a listing representing the fixed face very much like a feature in the Feature Manager tree. If I wish to make a change to the fixture, I can simply right-click on it and select Edit Definition. I can also change the default name of this fixture. And this is very helpful when you have a complex analysis with many different restraints. To change the name, you have to perform a slow double click. Click the fixture to select it, then pause, and click it again. I'll type in the name Fixed Face. For this analysis, the single fixed face is the only fixture I need. Notice that the fixed face completely prevents motion in this part. That is the critical requirement when it comes to adding fixtures. You must add sufficient fixtures to prevent any type of rigid body motion. This makes our problem a static problem, which is the only type we can solve using SOLIDWORKS simulation. Later in the course, we'll see that SOLIDWORKS simulation does offer some tools that will automatically prevent rigid body motion. However, for now, Just keep in mind that you must add enough fixtures to your part so that it doesn't move when your load is applied.